I was watching those.
All right, got the title if you wanted it, Parallel and Perpendiculars. Dallas, you with me? Okay. Parallel lines are two lines in the same plane that do not intersect. Two lines in the same plane that do not intersect. Okay, lines, do they go on forever?
Yes.
Some do, some don't?
Lines do, segments don't, rays don't.
Okay, so if I'm asking line, does line go on forever?
Yes.
Yes. In both directions? Yes. Okay. Correct. It's rays that go in one direction, segments don't continue on, so there is a little bit of difference between those things. What's a plane? It says that they're in the same plane,
Flat surface.
a flat surface. So you can imagine both of the lines like on the floor, or both of them on the front wall, or both of them on the ceiling, that type of thing. Two lines in the same plane that do not intersect. What's it mean if they intersect? We defined that term in chapter 1. They cross. They would share a point. Okay, so this is saying the two lines that are parallel don't share any points at all. So they're side by side, headed the same direction, kind of like the tracks of a train. The two rails have to be the same distance apart consistently, otherwise your train's going to have trouble there. They do not intersect. There is a symbol that we use for parallel, and it is two lines straight up and down. And here's a diagram that shows two lines. The arrows on the end indicate they keep going on forever. The blue extra arrow that I put on there is the symbol on a diagram to show parallel. So even if I haven't drawn it exactly perfect, the arrows on there clarify that's my intention, that they are parallel, that they're not going to intersect. So to use that symbol, if this were line L and this were line K, I could say L, maybe I should put line. Line L is parallel to line K. The small script letter was a way that we could name the line. Another way would be if you had points on it. Points are capital letters. So if I use those capital letters in order to indicate the parallel, I would say line AB is parallel to line CD. So reviewing from chapter 1, the line symbol, now we have this parallel symbol. So in the room, can you give me some specific examples of things that would be like lines that don't intersect? Okay, the top silver part and the bottom silver part on that, correct? They're in the same plane. Awesome. The ceiling and the door and the floor. Okay, the ceiling is like a plane. I think you're giving me two parallel planes rather than two lines. Okay, so go a little bit more just lines. So what in the ceiling could we describe as lines?
Lights.
Okay, maybe a row of lights and another row of lights.
Yeah.
What's a good example from the ceiling?
The crossbars that
Yeah.
hold the tower.
Right, those crossbars. So if those crossbars go the same direction, they're parallel, they're parallel. Maybe the rows of desks in the room, that might be a little bit more out of the box kind of thing.
What about Dustin? Dustin's parallel.
What's parallel?
Dustin. His legs
He-
are.
I was gonna say, he would have to be parallel to something else.
Dustin and Colton are parallel.
No, it's not, 'cause
Maybe, I'm not sure that they are. If they were standing side by side, I might say that they're parallel. But if they're just sitting the way they are right now, they don't appear to be parallel at all, because they're not really lines.
That's that age.
Okay, another term is perpendicular lines. Two lines that intersect to form a right angle. So they don't just intersect, but they intersect to form a right angle. Dallas, new notes? Intersect to form a right angle. How many degrees is a right angle? 90. Can't write and think at the same time.
Actually, your brain doesn't actually function as once that test because it thinks you're still doing only one task.
Probably very quickly changes from one to the other.
But you're still doing one task.
Okay, there is a symbol, this upside down capital T looking thing, that is the symbol that means it's perpendicular to. In the diagram with the two intersecting lines, we have that little square corner there. That indicates that that's a right angle, a 90-degree angle, so those two lines would be perpendicular. My picture off to the side, that tall skinny tree, perpendicular to the ground. Okay, so again, as far as symbols,
It's true.
if this is line L and this is line K, to use the perpendicular symbol, I would say line L is perpendicular to line K. If you had the points on there, MN, PQ, we would say line MN is perpendicular to line PQ. So that symbol means it's perpendicular to, which according to the definition means what? Perpendicular means two lines that intersect to form a right angle. Okay, look around the room. Where are there two lines that intersect forming a right angle?
Okay, the chalkboard or the black tape.
Now again, if you go to floor, that's a whole plane.
It's not.
Give me lines.
The
The
corner.
black tape, okay, the black tape's possibly, I haven't measured my angles, but freehand it looks pretty good there.
So like that road heads and that one heads.
Oh
Okay,
my.
which ones did you say?
That one and
Okay, so he's looking at a row of lights going this way and a row of lights going that way. Correct? Or the little dividing metal strips going that direction
Or
and that
the-
direction.
The corner,
The corner
No,
of
it's
the
the
room
wall
or
going-
the,
the wall going up and then the wall.
see, I'm kind of hesitant for you to tell me a whole wall. Because a whole wall is a whole plane.
Like
Give me
where the
lines.
walls connect, I mean.
Okay,
That.
where the edges,
Yeah, like the corner.
so like that top edge
Yeah.
and the edge going up and down,
that's what I was saying.
okay, is that what you were saying? I think you said like the floor and the wall. Where the floor and the wall meet, so maybe that trim down there, and then, I can't really see the corner going up.
Why are you guys making them so
So,
complicated?
Have to be a little bit more specific what you're telling me.
See if you can think of one.
Okay, what else is perpendicular in the room? Perpendicular lines.
Oh, that little line, that
On the little blue thing?
little thing that's hanging up on the
Yeah,
ceiling.
that's
Oh,
thinking
that-
outside of the box. I like that.
Are they 90-degree angles?
Oh, never mind.
Probably not 90, but which model up there has more of a 90 degree?
Squares.
Yeah, so the brown one would be a better example.
If
of
you had a
perpendicular.
lowercase t up there.
If I had a lowercase t on my bulletin board,
Yeah.
how about the capital T,
That would work.
or the capital L, or the capital E?
Well, I didn't think so because the top of it is like it's not like it doesn't the line doesn't go through it or
I guess if this is a 90-degree angle right here,
yeah.
then
That
this
works.
part would be perpendicular to that part.
Okay.
As long as it's 90. Jamie, what was your idea? The border on it, okay, my bulletin board border, like the edges of it. All right, well, let's move on from perpendicular. Skew. Skew is a term you probably haven't heard yet. Skew. two lines that do not lie in the same plane and do not intersect. Now, parallel, we said they didn't intersect, but they were on the same plane. Skew lines don't intersect either, but they're not on the same plane. About parallel, perpendicular, and skew. Give me thumbs up or down. Are you able to pick those out? Dallas, you're not with me. Dallas. Dallas. You're not with me. You're gonna owe me some time. Okay, how are we doing on parallel, perpendicular, skew? Got 'em? All right, let's go on. So what relationship do the skis on this skiing picture indicate? Trying to do parallel. Perpendicular, kind of obvious with the marked in there.
It looks like somebody just got.
Perp.
Can you see a skew possibility there?
Yeah, because the other person's bored.
This one, maybe
Actually,
this
that
one,
one guy always has like half of a.
maybe even those. It's kind of behind. Alright.
How did this make
Yeah, you can't see the other part of it, can you? Maybe it's broke off, maybe it's coming forward. Okay, let's move on to planes. Earlier, some of you were giving me like the floor and the ceiling.
Yeah.
Those are planes that are parallel rather than just lines that are parallel. Okay, parallel planes, two planes that do not intersect. So I'm trying to draw in my pictures so that you're visualizing like a floor and a ceiling. And to me, the one on the right really gets more of their separate idea. This could be interpreted as two planes that are really the same. So by overlapping them a little bit and using the dashing, I think that gives you a better picture that they are at different levels rather than the same plane. So two planes that intersect. So the floor and the ceiling, the front wall, the back wall,
The two side walls.
the side walls, maybe the side wall and the wall that has the door there, that little section.
You could do like the side of this side of the cabinet, the side of this cupboard.
Correct.
Wait, so
The
they
front of
don't
it, The
intersect?
back of it. Parallel planes do not intersect, okay? Now, are you interpreting this correctly in your mind? It's like
Yeah,
one
because the
higher, one
dotted
lower,
lines,
because of the dashed lines that are in there. Okay, parallel planes. And we can have perpendicular in relation to planes, not really a plane perpendicular to another plane, but we talk about lines that are perpendicular to a plane. Okay, a line that intersects a plane in a point and that's perpendicular. Over here.
I didn't know that was such a thing.
I didn't know there was such a thing as dot paper.
Yeah, do you remember like that dot game where you have to draw the boxes you and your friend and then you fill in the letter if you made a box?
Yeah, there is a game that you can play
Yeah.
on. Like you try and form triangles maybe or squares. What?
Yes.
No, and access.
From one,
Yeah.
what is that, one something?
Okay. If it takes you that long, you're allowed that long. Okay, a straight edge would really help. Do you have ruler handy?
Oh, you need one more.
Some of you have those? Okay, we'll try a little drawing with the dot paper and then without it. Okay, trying to draw a prism. Okay, a prism, this one is a rectangular prism, basically a box. Okay, if you use using the dots on the dot paper, and I don't know if my dots match up when you turn it sideways or straight up and down. Okay, to draw it, what I would suggest you do is start at one part of it. Let's draw the front. So on your paper, draw between some dots going straight up and down. The number that I did was I had 1, 2, 3, 4, 5 spaces, but it's up to you. Okay, and then horizontally, here my dots are spaced wider. I went with 2 dots. So I don't know if that matches up with your paper or not. Yeah, find the ones that go. So as long as the height and the width, you do the same on those 2 sides and then finish it. You make a rectangle to represent the front of the box. Rectangle for the front of the box. Okay, so now what I suggest on the dot paper is you do the slanted things. So go from one corner, maybe this top one, and see where the diagonal goes. Draw yourself however many spaces you want to go diagonally.
I got it.
Now do the same diagonal from every corner of what you drew to start with. And if you're drawing in pencil is good because this one's going to be dashed because it's hidden. So draw the same slant and the same number of spaces on the slant.
Does that look good?
Yeah, that does. Only thing you don't have is what's dashed.
Well, I did draw it, but solid.
Yeah. Why do we need the dashing? So that your brain knows what's in front and what's behind. So then once you get those, you've got these 4 corners now, the ends of your diagonals. That's what you connect to get the back of the box. So it should match up. The edges you're drawing should be parallel to the front of the box. Going horizontal, vertical,
Like that.
horizontal dash, vertical dash. Let's see. Doesn't look like a box, doesn't it?
Oh, yeah.
Usually if you hold it away from you a bit, you can tell. What did you do different? The slant that you went here, the slant that you went here were definitely different. So if you're going this slant, you have to do that slant on this side also.
I can go home and say I learned something. How to draw 3D things.
And you got the dashing, so it really does look 3D.
Yeah.
Okay, let's try another prism. Let's try a triangular prism.
Wait, can you go back for just one
For
split?
just a split second. There you go.
Okay.
Please tell me this matters. Yeah.
Right now, the way that I position this one is like the doorstop. And so I would suggest you draw the triangle first. Okay, go vertical and horizontal to draw 2 edges of your triangle. And then the way I have mine, when I go diagonal, it does go along some dots. So if you need to go longer on your triangle edges, maybe go with one of them and then go diagonal and see where it meets up. Draw a diagonal, see if you can get it lined up on dots.
Yeah, I think I just built another square.
3 sides instead of 4. Okay, then remember the diagonal for the edges going back. So along the dots going slanted, count how many spaces you do. Go along the same diagonal, the same number of spaces for all 3 of those.
Oh, I built it too far.
That'll give you the 3 dots to connect for the back.
Built another square.
Swag.
Okay, so you might try and do like a right triangle.
So,
Maybe we'll go slant. See where they meet.
okay. It's kind of confusing.
This one, you went on your assignment. And the last thing that I want you to do is a little bit of calculating slope. Okay? So you've got some dot paper, you can like put that behind your homework even when you're drawing for your assignment so you see the dots. but you're not really using the dots. So you might want that dot paper, the backside of it, to help you with homework. Okay, let's do a little bit of calculating slope and then we'll do some homework time. Slope you studied in algebra. Slope indicates the slantedness of a line, like how steep it is, how slanted it is. And it does also indicate whether it's slanted up to the right or down to the right. So I don't know if you want all the words or mainly the formulas after you've done the first sentence. One way that we talked about slope is that slope is rise over run. How much you rise compared to how much it runs. And when you rise, if you're going up, it's positive. If you're going down, it's negative. The run, if you're going to the right, it's positive. If you go to the left, it's negative. So you probably did draw some in on a graph and counted rise and run. We're actually going to start with 2 points. So I don't know that you want to graph it all the time. So by calculation, we're going to use the formula that we mentioned on the review, state review at the beginning today. Slope is calculated by y2 minus y1 over x2 minus x1. So having the notes that I've circled would be important from this screen. Reminder, a point is an x and a y all the time. So x and y from the first point, and then x and y from the second point. So on the board, I'm going to give you a couple of points, and we're going to do a few calculations of slope.
Hold on.
I'll leave that up there.
Okay.
Okay, let's go with point A as being 10.4. And point B as -8.6. I want you to calculate what the slope is. Calculate the slope. It might help under each point to put the x1, y1, x2, y2, so you know what numbers you're using. You can't switch the order of the ones and the twos, otherwise your answer is going to be off by the positive and negatives. So go something like this is x1, this is y1, this is x2, this is y2. The formula says to get the slope that we call m,
Is the slope
I got it right a long time ago.
Just class.
You start ignoring it.